Looks good. Let me go ahead and go over to YouTube and grab the chat so that it is embedded in the stream. Boom, boom, boom. There we go. So we are streaming over on YouTube. We're about 10 seconds behind. Let's just make sure that the sound is working. Close this down. Grab our chat. Here we go. Stream is up. Stream is running. I need to make sure that all of my elements are saved as well. Yep. Good, good. All right, so let's go ahead and copy. Want to do pop-out chat. We'll grab the chat URL and can go ahead and close it. I'm going to go ahead and close this window here. Go into, there we go. I need to go to properties and I'm going to go ahead and apply. There we go. Good, good. So we'll make sure, looks like it's coming through very well, very well. Okay. Looks like we're set. Bada boom, bada bang. Good. Good. All right. So, hello everybody. What is this stream about? Well, as the title says, this is Mathematics Review and Practice, and this is Arithmetic. So, the book that I am going through currently, it is purely review. So, what we're doing is we have Augustus de Morgan, who's a famous mathematician, a famous English mathematician. He's given us some laws pertaining to logic and the like. So he gave us rules pertaining to logic and also helped with mathematical induction. He wrote this Elements of Arithmetic, okay? So the purpose of this stream is essentially just to do a quick review of information that is in the public domain. So these books are available on Google Books. You can actually look at them on Google Books. There's a link down in the description to the to my library in on Google Books, where I put all of these math books that, once again, free, open, available for reading, and just a really good source. So what we're going to do is we are going to go through this particular text, and we're just going to do a pure review. And actually, I need to pull up. I realized I closed down one of my applications, and we're going to just make quick notes, and if there's any sort of information that we need to hold, then we will. Hold on, let's see. Open workspace folder. There we go. I need to do open. We don't need that. We need open workspace folder, and we're looking for mathematics. There it is. Done. Where are you at? Documents, mathematics. There we go. All right. So we're all set, ready to go. And good. We have our document viewer set up here. Okay. So the book is Elements of Arithmetic. The Elements of Arithmetic. Elements of Arithmetic. Okay. That is, and we could do cursive. Why not? I'm actually feeling pretty good about cursive right now. So we have elements of arithmetic. Okay. There we go. Let's go ahead and do the middle size. That should work. So that is the subject. That is what we are studying. Let's go ahead and make sure that the screen was it updated to the newest version of our notes? It does not look like it. So let me go ahead and make sure that we have the correct selector going. And our note, share. Good. All right, so elements of arithmetic. Now, what we're going to do is we're simply going to be reading through, and on particular notes or concepts, we will write those down. But beyond that point, we'll just sort of continue to skip through, okay? So elements of arithmetic, and here we have, this is called the principles of arithmetic, right? Oh, and we have, looks like we are frozen a little bit, so let's go ahead and reload that page. Here we go. There we are. All right, so let's make sure that it is updated here as well. Open selector, application window. We need elements of arithmetic, share. All right, so now we open up Zernal, or we open up Arnote. We're set. Okay, so here's the book. Book 1, Principles of Arithmetic, Section 1. The only information we need here is we're going to look at the section number. So this is going to be section 1. And in this instance, it is numeration. The word here is numeration. Okay, there we go. Numeration. And now we'll read. So here's any points that we need will be made under paragraph 1, okay? Imagine a multitude of objects of the same kind assembled together, for example, a company of horsemen. One of the first things that might strike a spectator, although unused to counting, is that to each man there is a horse. Now, though men and horses are things perfectly unlike, yet because there is one of the first kind to every one of the second, one man to every horse, a new notion will be formed in the mind of the observer, which we express in words by saying that there is the same number of men as of horses. A savage who has no other way of counting might remember this number by taking a pebble for each man. Out of a method as rude as this has sprung our system of calculation, by the steps which are pointed out in the following articles. Suppose that there are 2 companies of horsemen, and a person wishes to know in which of them is the greater number, and also to be able to recollect how many there are in each. Okay, so what is the takeaway from there? Ultimately, the takeaway from there is that there is a relation. If we look here, now they are perfectly unlike, yet there are the same number of men as of horses. Okay? And if we're looking for, this is called association. Okay? So we would say the one takeaway from this paragraph would be that we are talking about an association of 1 to 1. So the sentence would be with numbers, okay? With, and let me zoom in here just a little bit, okay? With numbers, comma, there is, let's see, you could say, with numbers, an object or an item, this is an E, an item, we can spell this correctly, may be associated with another item. With another item. Or, and so we'll do colon, one counts for one, or one holds the place for one. One holds the place for another. One holds the place for another. Let's rewrite that. Holds a place for another. Okay? There we go. With numbers, an item may be associated. Here, we'll actually change this here. I need to go ahead and clean this up here. Let's do maybe. May be associated. So 1, with numbers, an item may be associated with another item. One holds the place for another. Okay, so that's the first paragraph. Moving on to the second paragraph. Paragraph number 2. Okay, so we'll go down the page here. Suppose that while the first company passes by, he, that is the one who is counting, drops a pebble into a basket for each man whom he sees. There is no connection between the pebbles and the horseman, but this, that for every horseman there is a pebble. That is, in common speech, the number of pebbles and of horsemen is the same. Suppose that while the second company passes, he drops a pebble for each man in a second basket. He will then have 2 baskets of pebbles, by which he will be able to convey to any other person a notion of how many horsemen there were in each company. When he wishes to know which company was the larger, or contained most horsemen, he will take a pebble out of each basket and put them aside. He will go on doing this as often as he can, that is, until one of the baskets is emptied. Then, if he also finds the other basket empty, he says that both companies contained the same number of horsemen. If the second basket still contains some pebbles, he can tell by them how many more were in the second than in the first. So what's the takeaway from the second paragraph? The takeaway from the second paragraph is that you are able to, by grouping, so with numbers, an item may be associated with another item. One holds the place for another. In the case of the second paragraph, the groups, so you can group different items, right? So groups of items may be compared as to which one is larger, smaller, or equal, right? So groups of items. Here's the takeaway. Groups of, let's make this just a little bit bolder, so let me use a smaller. Here we go. Maybe the medium. And can we do a little bit density? Can we do simple, modeled? How about this one? Textured? No. Let's do solid. There we go. And we'll just have to practice drawing. So we go groups of items. So here's the takeaway in one sentence. Here's the takeaway from the second paragraph. So in paragraph 2, it's groups of items may be, and then it can be one of 2 things, right? So he says in here, they may be compared, so they may be compared. And then once they are compared, to see if the groups are, and then colon, A, the same in number, B, different So different. This is different in amount and by how much. Okay, so that's the second takeaway. Groups of items may be compared to see if the groups are A, the same in number, or B, different in amount and by so much or by how much. Okay, so that is the takeaway from paragraph number 2. So we continue down the page and we have number 3. So this is paragraph number 3. One of the nice things about old math books is that every single paragraph number is numbered, or every single paragraph has a number associated with it, and so therefore it's easy to understand and to keep track of. Okay, so 3. In this way, a savage could keep an account of any numbers in which he was interested. He would thus register his children, his cattle, or the number of summers and winters which he had seen by means of pebbles or any other small objects which could be got in large numbers. Something of this sort is the practice of savage nations at this day, and it has in some places lasted even after the invention of better methods of reckoning. In Rome, in the time of the Republic, the praetor, one of the magistrates, used to go every year in great pomp and drive a nail into the door of the temple of Jupiter, a way of remembering the number of years which the city had been built, which probably took its rise from the introduction of writing. Okay, so what do we have in here? The takeaway from the third sentence is the concept or the idea that you can use numerous small items to create associations and groupings of various types. Okay, you can use numerous. So by use of numerous, minuscule or small, by using numerous and easily available objects, objects or things, objects. Let's see if we can clean that up a little. It's interesting getting used to the layout for our note. Objects. By using numerous and easily available objects, one can keep track or keep count of many different types, many different categories, many different kinds of things. Kinds or categories, kinds or categories of items. Okay, so by using numerous and easily available objects, one can keep track of many different kinds or categories of items. Okay, that's the takeaway from the third paragraph. The next point, this is number 4. So this is paragraph number 4. In process of time, names would be given to those collections of pebbles which were met with most frequently. But as long as small numbers only were required, the most convenient way of reckoning them would be by means of the fingers. Any person could make with his 2 hands the little calculations which would be necessary for his purposes, and would name all the different collections of the fingers. He would thus give words in his own language answering to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. As his wants increased, he would find it necessary to give names to larger numbers, but here he would be stopped by the immense quantity of words in which he must have in order to express all the numbers in which he would be obliged to make use of. He must then, having given a separate name to a few of the first numbers, manage to express all other numbers by means of those names. So, what is the takeaway from there? The takeaway from there is that when you encounter multiple types, or you will have a certain number of items, or that are commonly considered. So of course this is your numbers 1 through 10, and in this way, each of the groupings, each of the small groupings of pebbles, if you will, would be given a particular name. So the takeaway from there, in one sentence, it would be, as his wants increased, he would find it necessary to give names to larger numbers, but here he stopped by the immense quantity of the words in which he must have. So we would say that a reasonable, that commonly, the takeaway there would be commonly used groupings of items were given specific are given specific names. Okay, so we have commonly. So this is commonly used or encountered groups of items are given or are associated uh, with specific names. Commonly used or encountered groups are associated with specific names. Okay? There we go. Now we're going to go ahead and list them here as well. So notice that he gave them, he could use words in his own language answering to 1, 2, 3, 4, 5. So we're going to go ahead and just give a quick example of that. So commonly used or encountered groups. So an example would be, or the example would be, example 1 item corresponds to the word 1. For obvious reasons, but we'll just humor me for right now, okay? So we have 1, and then we have 2. 2 items corresponds to the word 2. 3 items is or corresponds to 3. 4, 1, 1, 2, 3, 4 corresponds to 4, the word. So notice how the group of items corresponds to the word. And then 5, now here I'm going to start going into groups below. So now we have 5. This corresponds to the word. So that grouping right there corresponds to the word 5. And then this grouping here corresponds to the word 6. This grouping here, this grouping corresponds to the word 7. This grouping corresponds to the word 8. This grouping here and you can see how with each grouping it would be more difficult to have to count every single time. So the more items you have, it's actually better to have the words for them, right? And then we have the next one, the final one that I'm going to have in this example is going to be 10. That grouping right there corresponds to the number 10, or corresponds to the word 10. So you see that each of these groupings corresponds to a particular word, 1 through 10, okay? And that's essentially what he said. And as we add more and more, it becomes difficult to, you would have the sheer number of words that you would have for each of the numbers would be too much, right? So now we'll go forward, and now so that was the 4th paragraph, and now we have paragraph number 5, okay? So this is paragraph number 5. I now show how this has been done in our own language. The English names of numbers have been formed from the Saxon, and in the following table each number after 10 is written down in one column, while another shows its connection with those which have preceded it. Okay, so let's go ahead and let's see here. 1, 11, 10 and 1, 2, 12 and 2, 3, 13, 10 and 3, 14 is 4, and then 14, 10 and 4, 5, 15, 10 and 5, 6, 16, 10 and 6, 7, 17, 10 and 7, 8, 18, 10 and 8, 9, 19, 10 and 9, 10, 20, 2 tens. Okay, so you see he's listing out all of these different examples, and we would show that as he does give the answers, or he gives the reasons why 1 and why 11 and 12, why they have some a special name associated with them. Okay, go ahead and grab a little water. So the question remains if it's necessary to write this out. I'm not going to necessarily, but what we do want to do is, while 10 is written down in one column, while another shows its connection with those which have preceded. Columns. So this idea of columns, okay? And so in the language itself, the word, so the takeaway here is that a word can show not only the amount of items, it can also show the position of the items, the column position, okay? So you would say words words that correspond to numbers, that correspond to groups, right? That correspond to groups may show not only the total grouping. Words that correspond to groups may show not only a total group count, a total count, or a total count, but also the necessary, or the you could say necessary or pertinent maybe would be another word, but we'll do necessary. The necessary subgroups, right? The total count, the necessary subgroups. Subgroups for ordering, or for better understanding, right? So words that correspond to groups may show not only a total count, but also the necessary subgroups for better ordering, or for better categorization, okay? For a better ordering would be better, would be a cleaner word, I think. For better categorization. Categorization. Okay? So there we go. Words that correspond to groups may show not only a total count, but also the necessary subgroups for better categorization. Okay? And that's what De Morgan is speaking of right here when he says that the following table, each number after 10, is written down in one column, while another shows its connection with those those that have preceded it. Okay? So you see here how 1, the 11 is 10 and 1, 2 is 12 and 2, 3 is 10 and 3, 4 is 10 and 4, 5, 15, 10, 5, 6, 16, 10, 6, 7, 17, 10, 7, 8, 18, 10, 8, 9, 19 is 10 and 9, 20 is 10, 20, 2 tens, okay? And then he keeps on going. 21, 2 tens and 1, 22, 2 tens and 2, etc., etc., for the 50s, for the hundreds, all the way down to 10,000, okay? And then he continues, 100 million, what was this, 100,000, a million, 100,000, or 100,000, 10 millions, 100 millions, and so on and so forth, okay? So if we were to show that, he does have that note here about why the name 11 and 12 would be different, and there's the idea that it's possible that the name is derived from the Saxon for one left and two left, meaning after 10 is removed, but there seems to be better reason to think that 11 is a word meaning 10 and connected with a decim. So that's just a little bit of the history behind there, okay? We won't worry ourselves with it too much. But words that correspond to groups may show not only a total count, but also the necessary subgroups for better categorization. So examples of that, we have words like, because does he go on and then talk about the numbers? Not really. So he talks about the distinct signs, right? So we're not going to write all this down. It's just enough to have this sentence right here. That's the main takeaway, okay, from the fifth paragraph. And then going forward, we now need the sixth paragraph, okay? So we have paragraph number 6, and in paragraph number 6, he says, words written down in ordinary language would very soon be too long for each continual repetition as takes place in calculation. Short signs would then be substituted for words, but it would be impossible to have a distinct sign for every number, so that when some few signs have been chosen, it would be convenient to invent others for the rest out of those already made. These signs which we use are as follows, okay? And then he gives us the Arabic symbols for that for the numbers, okay? So if we jump back here, what he's talking about is that this commonly used in paragraph number 4, commonly used or encountered groups are associated with specific names or words. Those specific names or words, which are this grouping of 10 right here, and then of course he gave more of the names earlier in the page, right? 50, 60, 70, 80, 90, 100, and so on and so forth, the various names for the numbers. Those words, if they were repeated often, they become rather tiresome to have to write those words every single time. So what we do is every single word is then associated with a particular sign. It's given a distinct sign, okay? So what are those signs? We'll go ahead and list them out in the order in which he has them here. We'll probably continue to go linear, okay? So if we have not means nothing, right? So we'll have that. We'll write the word on the left-hand side and then the sign on the right-hand side. So we're going to do word, word, and sign. Word and sign, okay? Here. And we should actually be able to just show this since we're writing on ruled paper. It's pretty easy to make the distinctions. So this is the word. The word itself is not, or another way to say it is 0, right? So we have not or 0. Okay? And then the sign is 0. Just a circle with a line through it. Okay? The next word is, so that's not, and then of course we have 1. Now, obviously I've already been using them, and this is a review, so most of the time, you know your numbers. I'm not trying to teach anything new. This is merely an attempt to be somewhat coherent in the review and to start from the basics and work up kind of an iterative process, okay? So not 0, 1, 2, and then 3. Here's number 3, 4, and here is the 4th item. Here we go. Okay, yeah, let's make it a little bit better. There we go. 4, and then we have 5, 6, 7, 7 is also written with a line through it like that, but we'll just do the strict diagonal right there. 8, and 9. For a total of 10 symbols, right? These 10 signs, 0 through 9 are the 10 signs, okay? Now, what's the takeaway from here? The takeaway idea that we could then turn into something that helps us with our understanding is that it is easier to use, or when words are in frequent use, like numbers, when words / terms are in frequent use, it is easier, or it is more effective. It is more effective to use to signify them to signify their meaning with simple forms / strokes. So that's the takeaway. That's the takeaway from paragraph number 6. Is these are the signs, right? These are the signs. These are the words. All right? Signs, words, signs, words, signs. And so therefore the takeaway is when words / terms are in frequent use, it is more effective to signify their meaning with simple forms / strokes. Simple forms / strokes than to list their full name in every instance. So that's the takeaway. That would be a takeaway thought, okay? When words / terms are in frequent use, it is more effective to signify their meaning with simple forms or strokes than to list their full name in every instance. It is more effective to signify their meaning. You signify the meaning of something with a form or a stroke. All right? So now moving forward to page or to number 7, okay? So let's read through paragraph number 7. Suppose a man first to hold up one finger, then two, and so on until he has held up every finger, and suppose a number of men do the same thing. It is plain that we may thus distinguish one number from another by causing two different sets of persons to hold up each a certain number of fingers, and that we may do this in many different ways. For example, the number 15 might be indicated either by 15 men holding up one finger, or by 4 men each holding up 2 fingers, and a fifth holding up 7, and so on. The question is, of all these contrivances for expressing numbers, which is the most convenient? In the choice which is made for this purpose consists what is called the method of numeration. The method of numeration, okay? So the takeaway from here, or the takeaway from this particular paragraph, is the sense that that the total number can be grouped the total number of items can be grouped into different groupings, can be grouped into different subgroups. A total number can be rearranged into different subgroups. Okay, that's the first sentence. Then the second sentence would be the most effective in this choice, which is made for this purpose. So the most effective groupings. So you could say the most effective or the most efficient method of grouping is known as numeration. The most efficient method of grouping is known as numeration. Okay, so what we do here is it becomes a two-part sentence, in that we say the first portion is a total number of items a total number of items may be grouped be grouped into a variety of subgroups. And then it's a semicolon. Numeration, and we have to underline this because this is a term, right? You see in here it's italicized in the book, and so for us it's an important word. Important words are either in bold or they are italicized. So numeration is the most is the term used to describe is the term used to describe, well, if I can spell correctly, used to describe the most, we could say effective, or we can say the most convenient. In fact, he uses the word, right? The question is, of all these contrivances for expressing the number, which is the most convenient, right? So used to describe, so we have numeration. We could actually highlight that with a, well, we'll just highlight it here, and then we'll just know that underlined is what we're looking for, right? So numeration is the term used to describe the most convenient method of grouping. Is used to describe the most convenient method or a method of grouping. Might run out of room. We'll have to put it down here. There we go. Okay, so that's the takeaway. A total number of items may be grouped into a variety of subgroups. Numeration is the term used to describe the most convenient method of grouping. Okay, the most convenient method of grouping. That is what numeration is. Now, let's see what our good friend Mr. De Morgan, probably Dr. De Morgan says, 8. I have used the foregoing explanation because it is very probable that our system of numeration, and almost every other which is used in the world, sprung from the practice of reckoning on the fingers, which children usually follow when first they begin to count. The method which I have described is the rudest possible. By rudest he means the most simple. But by a little alteration, a system may be formed which will enable us to express enormous numbers with great ease. Okay, so what's the idea here? The idea here, the takeaway sentence would be that the modern system, in fact, we'll write it down as I go. So point number 8, the modern system, it is possible, it is, let's go ahead and fix this here. It is possible that the modern system, that the modern or current, modern or slash current systems of numeration, which we've already described before as the method of grouping, current systems of numeration derive from a more primitive and body-based grouping system. Body-based, and what that means is that we used our bodies to help us determine the grouping, okay? Body-based grouping system. Grouping method would actually be a better word. There we go. So it is possible, here's the idea, it is possible that the modern slash current systems of numeration derive from a more primitive body-based grouping method, okay? And that is essentially, that's the takeaway from paragraph number 8, okay? Now, just to backtrack, so for all of these various paragraphs that I've gone through, right? All I'm doing is I'm essentially taking the paragraph and I'm trying to put it in my own words. I'm trying to put it in my own words to then to have a stream of thought which would then be useful in later review and later study, okay? So when you are studying, you never want to just grab someone's thoughts right off the bat. You want to take it and say, what's he trying to say? What's the gist of what he's trying to say, okay? So that's the gist of paragraph number 8 Now we go to paragraph number 9. In number 9, it says, suppose that you are going to count some large number, for example, to measure a number of yards of cloth, and a yard is simply a unit of measurement. To measure a number of yards of cloth. Opposite to yourself, suppose a man to be placed who keeps his eye upon you, and holds up a finger for every yard which he sees you measure. A yard is about 3 feet, by the way. When 10 yards have been measured, he will hold up 10 fingers, and will not be able to count any further unless he begins again, holding up 1 finger at the 11th yard, 2 at the 12th, and so on. But to know how many have been counted, you must know not only how many fingers he holds up, but also how many times he has begun again. You may keep this in view by placing another man on the right of the former, who directs his eye towards his companion, and holds up 1 finger the moment he perceives him ready to begin again, that is, as soon as 10 yards have been measured. Each finger of the first man stands only for 1 yard, but each finger of the second stands for as many as all the fingers of the first together, that is, for 10. In this way, 100 may be counted, because the first may now reckon his 10 fingers once for each finger of the second man, that is, 10 times in all, and 10 tens is 100. And there's a note there. What does he say there? Oh, the references are in the preceding articles. So he was speaking of that's the ability to then go back and look at the I think the actual references to the bibliography. So now place a third man at the right of the second, who shall hold up a finger whenever he perceives the second ready to begin with. 1 finger of the third man counts as many as all the 10 fingers of the second, that is, counts 100. In this way we may proceed until the third has all his fingers extended, which will signify that 1000 or 1000 has been counted. A fourth man may enable us to count as far as 10,000, a fifth as far as 100,000, a sixth as far as 1,000,000, and so on. So what's the takeaway here? The takeaway here is that, so from paragraph 9, the idea is that you can have by having a different subgroup, okay? So let's say that every man, we'll actually draw the picture here for the idea, and then we'll do so we'll just do a little stick figure man, okay? There we go, Mr. Happy. So Mr. Happy, well, he's not happy because we're going to make him work. So Mr. Happy can hold up to 10 items, okay? So we're going to say that he holds, we'll call him H for happy, okay? H can count up to 10 items. Okay, so that's Mr. H. Mr. H can count up to 10 items, okay? Now, what happens when he can no longer count anymore? Well, we then have a friend of his, we'll call him, or hey, we will be inclusive. There we go. We'll say that it is Miss R. Okay? So we have R. We'll give her pigtails. There we go. Pigtails. There we go. All right. So Miss R can also count 10 items. Miss R can also count 10 items. All right. R can count 10 items. Okay, and then let's see, we'll do H, R, and then we'll finally end up with B, okay? And we'll say that B, we'll make him a little round fat man, okay? With a top hat. Why not? There we go. And there you go. He's been eaten well. All right, so we have Mr. B. Mr. B can also count 10 items. Mr. B can also count 10 items, okay? So we have H, R, and then we have B. And this is B can count 10 items. 10 items, okay? So what's the big takeaway? Our three friends are the subgroups. Our three friends are the subgroups, B, R, and H. Mr. B, Miss R, and Mr. H are all responsible for subgroupings. Subgroupings. And what are those subgroupings? 10 items. 10 items total, okay? So the takeaway here is that by careful or specific. Specific placement, and that's an important word. Specific placement of the subgroups allows us to keep track of of very large numbers. Or a way to say it would be specific placement of the subgroups allows us to keep track of of rapidly expanding numbers. Let's call it that way, okay? I'm sure that there would be an even better way to say that, but that's kind of the purpose of this you know, you have to throw an idea down, and then after the fact you can then revise it, okay? So specific placement of the subgroups allows us to keep track of oh boy, if I can spell correctly, come on, there we go, keep track. Someone's got to keep track around here anyway. Here we go, keep track of rapidly expanding numbers or rapidly growing numbers. Rapidly growing numbers. All right. Another way to say it, because this is actually, it's so fascinating that very often we sort of blow by this idea that that placement is important, and because you normally encounter placement when you're very young in your studies. But the idea of placement, of a geometric placement, helping you to differentiate your order, your groupings, is actually a very fundamental idea, and it's almost revolutionary in a way. So the specific placement of subgroups allows us to keep track of rapidly growing numbers. Another way to say it is that the order of grouping, oh man, how do you say it in one sentence? How do you say it? The ordering. Oh man, this is where it gets tricky because I'm sitting here and I'm trying to figure out how to put it in a sentence. Um, the order of your uh, the positionality. No, the position of your counting item. The position of your counting item in space. Oh boy, oh boy, this is tricky. The position, how do you say that? The position of your counting. Let's actually try and write it down. So the the spatial position of the spatial position of your item tracker. We'll call it an item tracker. Item tracker /counter in relation the spatial position of your item tracker / counter in relation to like trackers, and by like that's similar, like / similar counters allows you to track and record much larger numbers, much larger quantities of items than a single uh, counter would, oh, we're running out of room, would be able to manage, or to manage. Manage is fine. Yep, we're running out of room there, so there we go. So the spatial position of your item tracker / counter in relation to like / similar counters allows you to track and record much larger quantities of items than a single counter would be able to manage. Okay? So that's essentially the idea, is that if you put item counters of this of a similar quality, where one item counter is linked to the other counter in a way where they're keeping track of each other, then you are able to, with this system of linked counters, a system of linked counters enables you to keep track of many, many more items than a single counter would be able to do it. That's the sentence. Okay, I think I've got it now. Third time's the charm. So a system, here we go. Let's try it this. A system of linked counters, of linked counters, computers is a term for it, tabulators, a system of linked, I'm going to say counters, like people who would be counting for you, of counters, will be able to keep track of more items then a single monolithic counter. That's the takeaway. That's the takeaway. A system of linked counters or linked tabulators or computers or what have you. A system of linked counters will be able to keep track of more items than a single monolithic counter. That's the takeaway, okay? So now, and that's essentially the takeaway for paragraph number 9, okay? All right, so now we move forward. Here's our next paragraph. This is paragraph number 10. Okay, each new person placed himself to your left in the rank opposite you. Okay, now rule columns as in the next page, and to the right of them, all place in words the number which you wish to represent. In the first column on the right, place the number of fingers which the first man will be holding up. Then, when that number of yards has been measured, in the next column, place the fingers which the second man will be holding up, and so on. Okay? So, we have this layout right here where he's talking about the different numbers. And he's talking about the columns, the positions, okay? So we're actually going to we will do our columns here, first, second, third, fourth, and so on and so forth. Now what we're going to do is create a similar layout here. So we will have our first column right over here, and we're going to call it the first, okay? So this is our first man, and we're going to lay it out here where this is first, okay? First is here, and then our second is here. Probably have enough room. First, second, third column. And can we do straight lines? I need a straight line. There we go. There we go. So there's our column. There's our first column. Here's our second column. Here is our third column. And then we're going to have our fourth column here. So we go back over here, and this is our fourth column. All right, and these would be our counters, right? These are our counting friends, the ones who are helping us keep track of the items. So in this instance, we would have 7 friends. We would have 7 friends. I'm going to go ahead and start the 7th over here and work backwards. So we're going to go, the 7th column is here, the 6th column is here, the 5th column is here, 4th column, 3rd column, 2nd column, and 1st column, okay? Let's go ahead and drop a line between each of them so that you can clearly see, okay? So we're essentially creating a grid just like the one behind us, but we're thinking more in terms of the columns, okay? So we have our columns here, and then finally we have our first one. We might need to zoom out a little bit to see everything all together, okay? All right, so we have that, and then we have different numbers. Now, he is using the Roman numerals for the numbers, so we'll do the same here. We have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and finally we have 7, okay? So those are our numbers, right? And we might need to go ahead and extend this down just a little longer. Here, 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 4 column. There we go. Here, here, and here. Okay? So in our first number, our first friend held up 7 fingers. Okay? So he was responsible, our first counter was responsible for 7 items. Okay? Our second friend would be responsible for 5 items. So he held up 7, our friend number 1 held up 7, our friend number 2 held up 5. This, of course, corresponds to the number 5 tens, 7, or 57. If we then put that over here, so the name there, we can then write it out as 50 hyphen 7. 57. 5 times 7. 5 times 7. Okay? And then our next one, our next grouping, if you were keeping track of, I think it was yards of cloth was in the example, right? Then our next grouping would be 4. 4 was held up by the first friend. Our second friend had no fingers that he was holding up, and then our third friend had 1. He was holding up 1 finger, okay? So this number would be 100, no tens, and 4, which is 104. $104. All right, so that would be the next number, 104. All right, next one. In the next example, this is our third number. Our first friend in the first column, he was holding up no fingers. Our second friend was holding up 1. Our third friend was holding up 1 as well. So this corresponds to 100, 110, no ones. So this is 110. 110. Our next number is, if we take a look at it, our first friend had 8 in the first column. He was holding up 8. Our second friend in the second column was holding up 4. Our third friend in the third column was holding up 3. And our fourth friend was holding up 2. So this would correspond to 2. 2 is in the thousands column. 3 is in the hundreds column. 4 is in the tens columm. And well, let's go ahead and put this up here so that we can differentiate between the different names, right? So let's go ahead and make this a line going across the top, like so. All right, so this corresponds as the thousands column, hundreds column, tens column, and ones column. So here it becomes 2,000, 300s, 4 tens, or 40, 4t, 4 tens, and 1 8. So that's 2,348. And I'm not going to worry about doing the other numbers because that's exhaustive. I mean, if you wanted, you could read through the book yourself. So I'm just going to stop at the fourth example, 2,348. 2,348. 348. There we go. Okay, so those are all the different groupings that we have. Each of the columns corresponds to a different counter, and each counter is linked. These would be considered linking, where one counter pays attention to what the next one is doing, and so on and so forth, and they don't activate until the one is done who came before them, okay? That's the idea of a system of linked counters will be able to keep track of more items than a single monolithic counter. That is the key. That's the takeaway from paragraph number 10. All right. Now paragraph number 11, let's go ahead and read it. and see what the takeaway is from that. All right. And let's see, did we clear up everything? Each person placed himself towards your left in the rank opposite you. Now rule columns as in the next page and to the right of them. So all of this right through here is the main takeaway from there, the main takeaway from uh, paragraph number 10 is that the main takeaway from paragraph number 10 is that the position, whether a number is left or right, is going to determine what other linker it is paying attention to. Okay, so the takeaway from us would be that the linkers or the counters, the counters to the left of the initial counter, the counters to the left of the initial counter are keeping track of increasingly larger quantities. The counters to the left of the initial counter are keeping track of increasingly larger quantities of increasingly larger quantities. Let's clean that up a little bit. Quantities. The counters to the left of the initial counter are keeping track of increasingly larger quantities. And in here, we know what it is. It's going to be by a factor of 10, okay? Increasing by a factor of 10. And we'll get into that later, but I'll go ahead and put it in here for our notes, knowing that I'm kind of jumping ahead in my terminology. Increasing by a factor. Actually, it's we can keep it in the same understanding, and that is what we do is we say the counters to the left of the initial counter are keeping track of increasingly larger quantities, and they're increasing by a factor of double, or it's a factor of double the counter to the right. Double the counter to the right. This means that once the counter to the right has completed their value, then you take their value, right? And so that's the idea. Increasing by a factor that is double, or that equals, yeah, there we go, that equals the highest, here we go, down here, that equals the highest item count of the counter to the right. To the right of the observed counter. The item to the right of the observed counter. So the takeaway from here is that the counters to the left of the initial counter are keeping track of increasingly larger quantities, increasing by a factor that equals the highest item count of the counter to the right of the observed counter. This means that as you progress one counter to the left of the one that came before, you take the total number of items that the counter previously was able to keep track of, and you say, this is what this new guy is now able to count. This new guy is able to count that number of factors times that number of factors. Okay, so a kind of wordy, I admit, and it would need to be cleaned up, but that's essentially the idea. Okay, so that one was paragraph number 10. Now we get to paragraph number 11. Okay, here's paragraph number 11. In number 1, the number 57 is expressed. This means 5 tens and 7. The first has therefore counted all his fingers 5 times and has counted 7 fingers more. This is shown by 5 fingers of the second man being held up and 7 of the first. In 2, the number 104 is present. This number is 5, is 10 tens and 4. The second person has therefore just reckoned all his fingers once, which is denoted by the third person holding up one finger. But he has not yet begun again, because he does not hold up a finger until the first has counted 10, of which 10 only 4 are completed. When all the last mentioned 10 have been counted, he then holds up one finger, and the first, being ready to begin again, has no fingers extended, and the number obtained is 11 tens, or 10 tens and 1 10, or 110. This is the case in 3. You will now find no difficulty with the other numbers in the table. So what's being said there? Well, what's being said there is that he's essentially just explaining the process of numeration, right? So the idea that if one man has no fingers being held up, he's just waiting until the next item, or until he's waiting until the previous counter maxes out his count load, and then he starts counting, and so on and so forth. And once a previous counter has maxed out his count load, he immediately reverts back to 0. Okay, so the idea is, um, let's see, one sentence that you could take away from number 11 um, is that when every counter maxes out their count value, or when when a when a counter, here we go, when a counter maxes out their total maxes out their total count, or their total limit, maxes out their total count limit or item limit, they pass they pass their total value, they pass their total value to the counter that follows them, that follows them. Let's go and move this down here. And let's see, when a counter maxes out their total item limit, they pass the total value to the counter that follows them and drop their item count to 0. Okay? When a counter maxes out their total item limit, they pass the total value to the counter that follows them and drop their item count to 0, keeping track keeping track of the item type they are assigned to. Okay? So when a linked counter, let's actually go put that in here. So when a linked counter maxes out their total item limit, they pass the total value to the counter that follows them and drop their item count to 0, keeping track of the item type they are assigned to. All right, I will be right back. Use the restroom. Back. Okay, so we're back at it. And so, as I said in paragraph 11, the takeaway from there is that when a linked counter, or a counter in a linked system, maxes out their total item limit, they pass their, and this is the essence of the linked system, is that they pass their information or their total count off to the counter that is linked to them. They pass it off to the one who follows them, and they drop their count back down to 0. And then they start to they start to keep track of the item type that they were assigned to. Every every counter in a linked system always keeps track of the item type they were assigned to. Every counter in a linked system only keeps track of the total number of items they were assigned to. The number of items of a specific type they were assigned to. Okay? So that was paragraph 11. They were assigned to. All right, now moving on, we take a look at paragraph number 12. In all these numbers, a figure of the first column stands for only as many yards as are written under that figure. A figure in the second column stands not for as many yards, but for as many tens of yards. A figure in the third column stands for as many hundreds of yards, in the fourth column for as many thousands of yards, and so on. That is, if we suppose a figure to move from any column to one on the left, it stands for 10 times as many yards as before. Recollect this, and you may cease to draw the line between the columns, because each figure will be sufficiently well known by the place in which it is, that is, by the number of figures which came upon the right hand of it. Okay? So, in this instance, what we're talking about, the takeaway from here is that in a way, this actually ties back to the previous, I think it was paragraph number 10, in that the positionality the positionality of a figure, and we can start calling them figures now. The positionality of a figure or sign indicates the value of 10 times the one that came before it. So what we can do, we can say this here for paragraph number 12. So in paragraph number 12, it states that in a system, so we'll put this here, in a system of counting where groups of 10 items are tracked and tabulated, every figure that stands to the right that stands to the right or sorry, that stands to the left hand, that stands to the left hand no, just left, that stands to the left of the preceding figure represents 10 times, represents 10 times. So it's are tracked and tabulated. Every figure that stands to the left of the preceding figure represents 10 times 10 times the previous count, the previous item count. Okay, that's the takeaway. In a system of counting where groups of 10 items are tracked and tabulated, every figure that stands to the left of the preceding figure represents 10 times 10 times the previous item count. Okay, there we go. Moving on. Paragraph number 13. It is important to recollect that this way of writing numbers, which has become so familiar as to seem the natural method, is not more natural than any other. For example, we might agree to signify 110 by the figure of 1 with an accent. Thus, 1, we could do like 1 with a little dash above it, okay? 20 or 2 tens by 2 with a dash, and so on. 100 or 200s by 1 with 2 dashes, 200 by 2 dashes, and 1000 by 1 dash with 3 by 1 with 3 dashes, and so on, putting Roman figures for accents when they become too many to write with convenience. The fourth number, let's see here, the fourth number in the table would have been written 2, so if we wanted, we could have written it as, so the fourth number in the table, which corresponded to 2,348, according to this section right here, said it could be written as 2, 3, right? Because that would be 3,000s, and then 3 with 2 little dashes for hundreds, 4 with 1 dash, and 8 with no dashes. 8 with no dashes, okay? Which might also be expressed by 8432 or 48321. So you see, once you have, he's saying that if you were to give them little monikers like this, then you could write them in any order and it wouldn't change. It wouldn't change the inherent value of the number because you would know based on the little check symbol that that would be the particular value, okay? So he's saying, which might also be expressed by 8, 4, 4 dash, 3 double dash, 2 triple dash, so on and so forth, or the order of the figures might be changed in any way because their meaning depends upon the accents which are attached to them and not upon the place in which they stand. Hence a cipher would never be necessary, for 104 would be distinguished from 14 by writing for the first 1 double dash 4 and for the second 1 single dash 4. The common method is preferred not because it is more exact than this, but because it is more simple. So what he's saying is that the column method is not the only way that numbers could be written. Some sort of other identifying factor could be given to them, but um, the reason why we don't go with the other methods is because they are more simple. So positionality makes the ability of writing numbers, of calculating numbers, it's the most simple method. Positionality increases simplicity using other methodologies such as the little dash marks increases it does allow you to be more exact with as far as what exactly a number stands for, but with exactness comes more complexity. Okay, so the note here, the kind of the takeaway thought would be the um, the common method, the common method of identifying numbers, the common 2m's method of writing numbers using, and in a parenthesis, it would be using positionality. Using positionality is not the most most exact method, is not the most exact method, but favors simplicity and ease of use. Okay, so that's the takeaway. It is more important to recollect that this way of writing numbers, which has become so familiar, it's not natural. It seems natural, okay? There are other ways to do it, but those other ways come at the cost of more of being less simple. So the big takeaway for us here is that the common method of writing numbers using positionality is not the most exact method, but favors simplicity and ease of use. Okay, and there we go. So that's the idea. All right, moving forward. Paragraph number 14. The distinction between our method of numeration and that of the ancients is in the meaning of each figure depending partly upon the place in which it stands. Thus, in 44,444, each 4 stands for something, but in the first column on the right, it signifies only 4 of the pebbles which are counted. In the second, it means 4 collections of 10 pebbles each. In the third, 4 of 100 each, and so on. So he's saying a distinction between our method and that of the ancients is the meaning of each figure depending partly upon the place in which it stands. So he's essentially just repeating himself. It stands for something, 4 of something. Each 4 stands for 4 of something. Okay, so the takeaway from paragraph number 4 is that I mean, he's simply just repeating himself in 14 because he said the same thing earlier. Um, he's merely pointing out that the distinction between our method of numeration and that of the ancients is in the meaning of each figure depending partly upon the place in which it stands. So what that means is that I know what it's um, the um, the modern oh, the modern concept of numeration differs from the ancient way in that the concept no the in that the type of quantity, or the quantity type, maybe the type of we'll stick with this one, the type of quantity reckoned by reckoned by linked counter always I don't know if this is really an argument. I'll finish it out, but I'm not quite pleased with it. But we'll stick with it. So, the modern concept of numeration differs from the ancient way in that the type of quantity reckoned by a linked counter um, hmm, always stands okay, I think I see it, of a linked counter always stands for uh, for always stands for a value of values. Okay, of a linked counter always stands for a value of values. A value of values, or a number. Second line down. Or a number of numbers. I think that's what he's saying. The modern concept of numeration differs from the ancient way in that the type of quantity reckoned by a linked counter always stands for a value of values or a number of numbers. A value of values or a number of numbers or a quantity of quantities. That's the takeaway. Okay? That's the idea. All right. So moving forward, next portion. So you see the distinction between our method of numeration and that of the ancients is the meaning of each figure depending partly upon the place in which it stands. And that's the idea of the linked counter. The linked counter, a type of quantity reckoned by a linked counter, always stands for a value of values or a number of numbers, comma, completely dependent. Oh, completely completely dependent hmm, I can spell dependent. Hold on. Yeah, I've got to check that one out. What is dependent? Depend. Yep, E-N-E-N-T. I tell you, those vowels sometimes get me. They really do. Completely dependent on the position, on the position of the tracker, or the position of the figure in relation to the other figures. All right. So here it is. It says the modern concept of numeration differs from the ancient way in that the type of quantity reckoned by a linked counter always stands for a value of values or a number of numbers, completely dependent on the position of the figure in relation to the other figures. Okay? So, you know what's so interesting is that, like, to me, based on what I know about things like computer science and about numbers in general and the way we understand the world, this concept right here, once again, we kind of blow over it because as children we are exposed to the idea of columns and everything. We completely blow by it, but this right here, this concept of numeration is extremely important. It's extremely important. So many different concepts in mathematics are built off of this very basic presupposition, this very basic assumption about positionality of value, positionality of value. All right, let's carry on. Paragraph number 15. The things measured in 11, and that was paragraph 11, were yards of cloth. In this case, 1 yard of cloth is called the unit. The first figure on the right is said to be in the units place because it stands for so many units as are in the number that is written under it, as in 6. The second figure is said to be in the tens place because it stands for a number of the tens of units. The third, fourth, and fifth figures are in the places of the hundreds, thousands, and tens of thousands for similar reason. Okay, the idea right there in paragraph 15 is so clear. What it's saying is that only the first counter, only the first figure is responsible for the actual tangible count of the item, the unit. Okay? The first figure is the only one that is really counting a number of units. Okay? Every figure to the left of the first figure is counting a multiple of units. A multiple of units, okay? So that's the idea. The takeaway here, the takeaway here is that only the first, let's see here. Every item that is being counted is called a unit. Okay, so that's the sentence right there. Notice once again, never write down what someone says. You always want to put it in your own words. Every, hold on, every item that is the subject of counting is called a unit, and unit is underlined because that is a key term. That's a very important term. Is called a unit. We're going to do semicolons here, okay? Only the first, only the first figure in the row, and by first we mean the one on the right-hand side, okay? Only the first figure in the row of figures is counting the number of units. Is counting the number of units. Every other figure, every figure in increasing distance from the first, in increasing distance from the first is tracking I don't think we can use multiple yet because we haven't identified a multiple, but what we can say is, so every item that the subject of every item that is the subject of counting, forgot that is the subject of counting is called a unit. Only the first figure in the row of figures is counting the number of units. Every figure in increasing distance from the first is tracking a unit of units, is tracking a unit of units. And I'm going to underline that because that's huge. Is tracking a unit of units. Okay? A unit of units, or a number of units, or a number or a group of units. A group of units. Let's clean up group a little bit. a group of units. Super foundational, right? A unit of units or a group of units. That's the takeaway from paragraph 15. Okay? Every item that is the subject of counting is called a unit. Only the first figure in the row of figures is counting the number of units. Every other figure in increasing, let's do other here. Every other figure in increasing distance from the first is tracking an increasing number of units, an increasing unit of units, or an increasing group of units. And that's key, okay? So the further you go from your initial value, your number of units is increasing. Okay? An increasing distance from the first is tracking an increasing unit of units, or an increasing group of units. Okay? And that's the 15th paragraph. Now we go on to the 16th paragraph. If the quantity measured had been acres of land, an acre of land would have been called the unit, for the unit is one of the things which are measured. Quantities are of two sorts, those which contain an exact number of units, as 47 yards, and those which do not, as 47 and a half. Of these, for the present, we only consider the first. So here he's simply saying that quantities, there are two types of quantities. We have those that are an exact number of units and those that are portions of a unit, okay? So a unit is one complete item of the things that are measured, okay? And then is one complete. Now, quantities can be of two sorts, those which have complete units and those which have incomplete units, okay? For the present, we only consider the first. So what we're going to say here is, in this sentence, is that a unit is a complete element. So we're going to say a unit is a complete element. Okay? A quantity, quantities may be made up of complete or incomplete, complete or partial units. Okay? If the quantity measures, so we can say the sentence here, essentially what he said, if the quantity measured had been acres of land, an acre of land would have been called the unit. So that actually already is summed up in paragraph 15. We don't need to repeat ourselves. Every item that is the subject of counting is called, right? Oh, there we go. Is called a unit. Every item that is the subject of counting is called a unit, okay? So 16, really the only point that we need to derive from 16 is the concept that there are two types of quantity, okay? And those quantity could be made up of exact units or partial units. Like every unit is one. So the idea here is that every unit is a complete part of the item. So a unit is the complete part, is the complete part of the item being counted. Quantity, so we have quantity, which is in cursive, that one would be yeah, there we go. This is quantity. Can measure, can be used to measure either units or can be used to measure both uh, both exact units exact exact numbers those are units or divisions of numbers or portions or portions of numbers. And those would be incomplete units. Incomplete units. Incomplete meaning that it simply, it was only a portion, right? Or portions of numbers. And this would be incomplete or partial units. All right. So that's the takeaway from 16, right? If the quantity measured had been acres of land, then the acre of land would have been called a unit. The unit is one of the things which are measured. For the unit is one of the things, okay? A unit is the complete part of the item being counted. It's the complete or the whole part, okay? Because a lot of things in this world are divisible, right? And divisibility, of course, is perfectly fine, but we think about it differently. So a unit is the complete/whole part of the item being counted. Quantity can be used to measure both exact numbers, units, or portions of numbers, incomplete or partial units, and that's quantity. Quantities are of two sorts, can be used, okay? There are two types. All right. And with that, that's all of 16. So now we can go ahead and close out that paragraph. And we have our next paragraph, which is going to be 17. So let's see what Mr. De Morgan says in paragraph 17. In most parts of arithmetic, all quantities must have the same unit. I'm going to grab a little drink of water first. Okay, so the next point in 17, we'll go ahead and read it. In most parts of arithmetic, all quantities must have the same unit. You cannot say that 2 yards and 3 feet make 5 yards or 5 feet because 2 and 3 make 5. Yet you may say that 2 yards and 3 yards make 5 yards, and that 2 feet and 3 feet make 5 feet. It would be absurd to try and measure a quantity of one kind with a unit which is a quantity of another kind. For example, to attempt to tell how many yards there are in a gallon or how many bushels of corn there are in a barrel of wine. Exactly. So the big takeaway from 17 is that like must be paired with like. Okay? So that's a good way to think of it is like is added to like. The unit type, or the unit, must be of the same type. The unit must be of the same type. Oh, must be of the same type before any comparisons or reckonings are conducted. There we go. So like is added to like. The unit or like is added to like. The unit must be of the same type before any comparisons or reckonings are conducted, okay? You have to only compare one thing of one type with another thing of the same type. You cannot do any sort of comparisons or measurings with different types. It's simply absurd. I mean, it doesn't stop people from doing it, but but you still can't do that. You can't measure one thing of one type against one thing of another. In fact, that would be another way to say it. No measurements. There is no valid measurement to be had between quantities of different units. Okay? So, there is no valid measurement to be had between quantities of different units. Like is added to like. The unit must be of the same type before any comparisons or reckonings are conducted. Okay? And that is the takeaway from 17. Moving on to 18. All things which are true of some numbers of one unit are true of the same numbers of any other unit. Thus, 15 pebbles has 7 pebbles together. Thus, 15 pebbles and 7 pebbles together make 22 pebbles. 15 acres and 7 acres together make 22 acres, and so on. From this, we come to say that 15 and 7 make 22, meaning that 15 things of the same kind and 7 more of the same kind as the first together make 22 of that kind, whether the first mentioned be pebbles, horsemen, acres of land, or any other. For this it is but necessary to say once for all that 15 and 7 make 22. Therefore, in the future, on this part of the subject, I shall cease to talk of any particular units such as pebbles or acres and speak of numbers only. A number considered without intending to allude to any particular things is called an abstract number, and it is then merely and then it and in and it then merely signifies repetitions of a unit or the number of units a number of times a unit is repeated. Okay? And so the takeaway from that, oh, once I'm done knocking my bottle over, so the takeaway from here is that the rules that apply to measuring, comparing, and adding units or quantities of the same units applies to the exact same quantities of other units. All right? There, therefore, if you were to speak of, if you were to, as long as you have narrowed down, as long as you have met paragraph number 17, where you are always talking about quantities of the same unit, then all of your rules of tabulation, of adding and subtracting and all that, all of those rules are going to be the exact same for any quantity, provided that they belong to the same unit. All right? So let's go ahead and write that down in 18. Here we go. So 18, the takeaway from here is that one, the rules pertaining to quantity, the rules of measurement that pertain to quantity will are universally applicable. So the rules of measurement that pertain to quantity are are uni, universally applicable applicable. Oh, how do you spell applicable? Oh boy. Nothing better. Nothing humbles you like having to do research in front of a camera. Really. I tell you. You sit there and you think, "Do I know anything?" It is applicable. Yes. Okay, there we go. Applic and then able. Applicable. But once again, as Feynman said, the best way to show if you know something is by having to teach it, and it is for this reason, because then you see the holes in the way that you understand, you see the limitations to your knowledge, and it's just so applicable. So it swaps the order. Let's go ahead and fix that. It's just really good. It's really good for everyone involved. It's good for your humility, and it's good because then anyone who later down the line has to hear you speak, you've already had a chance to kind of get it out there. I mean, when you think about it, who am I hurting? Who am I hurting by sitting here and babbling to a computer? No one. And really, I'm growing because of it, because I'm having to wrestle with these ideas before I actually have to use them. And that's key. So like a lot of this language I'm using, of course I'd never use it with beginning students. I mean that's absolutely ridiculous. And it would never be intended to be used for beginning students. The purpose here is merely to get the ideas out of my mind as soon as possible, get them on the paper so I can begin to ruminate over what is actually being said. So there, I've spoken my piece. So 18. The rules of measurement that pertain to quantity are universally applicable once the unit of the quantities, and notice it's singular, the unit of the quantities is fixed. All right, that's the key. The rules of measurement that pertain to quantity are universally applicable once the unit of the quantities is fixed and set. All right, this means that provided you are always talking about units of, provided you are always talking about like and like, then all of the rules that are used of numbering are completely applicable. Okay, so now what he's talking about is he then gives a definition. A number considered without intending to allude to any particular thing is called an abstract number. So what we can do here is we can say the number when a number is considered independently, when a number is considered independently independently, there we go, something like that. Ugh, boy, that's ugly. Yeah, that's how you know I'm starting to get tired, when I start to get finicky about the way my lettering is written, or trying anyway. Independently. There we go. When a number is considered independently of its unit, it is called an abstract number. It is called an abstract number. Okay? And that's underlined because that's another term. It is called an abstract number. Period. And it then merely signifies repetitions of a unit, or the number of times a unit is repeated. Okay? So that's all there is to say about it. I don't know if I need to repeat that next one, because it's always understood. It merely signifies repetitions of a unit. So paragraph 18 is super important. The rules of measurement that pertain to quantity are universally applicable once the unit of the quantities is fixed and set. When a number is considered independently of its unit, it is called an abstract number. Okay? Independently of its unit. Most of us, when we're looking at numbers, we're not thinking about units. But it's so fascinating that every single number that you're looking at in this world every single number has a unit behind it. Every single number that you look at has a unit behind it, right? If you're looking at a page number, right? In fact, it's built in. a page number, turn to page number 300, 394. If you turn to that page number, you are talking the unit in question is pages. 394 is merely the quantity of the pages. So really interesting how that works. All right, and then paragraph 19. Now 19, I think, is just he is just repeating himself, right? So if we look at 19, I will now repeat the principal things that have been mentioned in this chapter. The first, 10 signs are used, one stands for nothing, and the rest for the first 9 numbers. The first of these is called a cipher. We actually want to make a note of that going back here to the previous paragraph. If I go back where he first mentioned that, which was number 9, I think. No, it was number 6, okay? Where a word corresponds to a sign, okay? We actually want to make a little note here that this is also called the cipher. A cipher is 0, and a cipher means nothing. A cipher means nothing, which is really fun because that's why in the X-Men, not X-Men, why Matrix, why the character in there, he is called Cypher. And it stems from this idea. The cipher is something that is nothing. It stands for nothing. It is merely a placeholder. And we need a placeholder that stands for nothing because we use positionality in our numeration. We use positionality in our numeration, okay? And that was, I think I actually did have that as an idea, but I might add that at 19 just to make it more clear that one of the values, so we'll go to 19 here, and 19, we're simply going to try and restate what he's saying. So the first point, we will follow his same principle. We'll break it down into 19.1, 19.2, so on and so forth. 19.1, the takeaway here, if we put it in our own words, is we say we would say modern numeration requires 10 signs. 10 signs. One sign as a mere placeholder. And 9 signs for quantity. Okay? So modern numeration requires 10 signs. 1 sign as a mere placeholder and 9 signs for quantity. And we can actually lay them out here if we want to go ahead and repeat it. And 9 signs for quantity. The placeholder, we'll add that as another sentence. The placeholder is called the cipher. Is called the cipher. There we go. And the placeholder. Oh boy. You can tell I've got 2 minutes left. I have 2 minutes left and then I'm done for tonight. Oi. Oh, come on. Wait, that's ugly. That is ugly. Here we go. Let's try this again. the placeholder is called the cipher. There we go. All right. So here we have the signs. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Of these, only these values show quantity. Shows quantity. And this placeholder. It means nothing. It is just holding a position open. This one is a placeholder. Like so. All right. And then moving on, here's our next point. And this is probably as far as I'm going to be able to go because I've got 52 seconds on the clock. But you know what? Ooh. Oh, he just repeats himself. And then he has the exercises. I'm not going to worry about the exercises in the stream. So the exercises would definitely be useful to do as short follow-up videos because that's where people might want to actually see that process separate from a stream. A stream is only necessary for ideation. It's where it's essentially for my benefit, where I'm having to wrestle with the ideas, I'm having to try and present them off the cuff or write down notes, so on and so forth. But as far as the actual exercises, that is much better suited for separate follow-up videos. So, I mean, obviously everything would be better as a separate follow-up video, but hey, we I I start where I can, man. So I'm gonna hold it there for right now. We got through the first 8 pages and some really good notes, um, like excuse me. Essentially, if we look at it, these are the notes that I took for the first 9 pages. Okay, and the idea once again, and it really is derived from the fact that I just finished the book How to Take Smart Notes by Sonke Arens, in which he describes that it's necessary to, as much as possible, to put concepts, it doesn't matter what the concept is, you try and put it in your own words. You don't copy someone else's words, you don't copy someone else's understanding. Um, so even though, I mean, as you see, I was much slower than if I had just tried to go through. The fact that I was wrestling with the concepts and trying to put them into other language, put them into my own words, means that in a way I understand it better, and I will then be able to present the ideas a little bit more effectively, hopefully, Lord willing, hopefully a little bit more effectively going forward. Okay, so thank you very much for watching. This has been the last stream for today, so it was 9 hours today, which was very nice, and I hope you all have a wonderful evening and got everything done today that you intended, and I hope that you're blessed and happy. So thank you so much, and until we meet again, bye bye.